So there's a big problem with engineering textbooks, and that most of them look like this. There's just like a bunch of derivations, equations, math, and there's like a little bit of text to support what's actually going on. And I've seen this as a trend in most engineering textbooks I've come across, especially in introductory courses, where the math in the textbooks is actually used to explain the concepts from scratch rather than as support for what's actually happening. And this happened to me when I started learning about electromagnetic waves on my own, and I got this textbook, and it was extremely technical, but then I went and I got this other textbook, and it's called A Student's Guide to Waves, and it was basically a lot of text and a lot of pictures, and only a small amount of equations was used to support the actual behavior that was happened only after it was explained visually and through text. And I think for introductory courses, this approach is way better, because what happens usually is you as a student, when you go into your first year, second year, whatever, and you pick up one of these like very technical textbooks on a topic you've never seen before, and you see like all these equations and they just come like right at you. While yes, these technical equations provide the solutions and the explanations for how things operate in the most accurate way possible, the way these textbooks are written ignores the psychological aspect of the student's beliefs. And any good teacher will tell you the most important thing about teaching is to capture the student's interest. And the reality is these textbooks, they do not capture the student's interest. Some portion of the students who go in and they have that like very strong math foundation and technical knowledge, maybe for them it's okay. But for a lot of students, and I'm willing to bet you're probably one of them, when you see like these textbooks with like all these equations and you can't really follow what's going on, deep down you start feeling stupid, and then because you feel stupid, you lose interest and you're like, oh, is this thing even for me? And this is why like engineering has been associated with like math, like side by side, which is not necessarily true. Math is only a tool that we use in engineering. Engineering is about innovation and ideas and concepts and visuals and using creativity to solve problems and innovate. We design things, we build things, and imagination and conceptual knowledge is far more important than how many equations you understand. Obviously, you need to know how to read equations and you need to understand the basics of how math operates. But in my opinion, math should not be the method to teach engineering concepts. It should only be the supporting part that explains the details of what happens once you have explained the concepts visually and through text. Now, if I were to suggest something better in the future to replace engineering textbooks, and this is going to be a bit futuristic, but stay with me because I think we could get there very quickly, is instead of something overly technical that like you read cover to cover, you go with a much more efficient way of teaching students. And that is when students ask questions. It's no surprise that the best way to learn something is to just follow your own curiosity and to ask questions, one question after the other, and then that leads you to the truth. So in this case, if I have a book about electromagnetic waves that's about like 700 pages, and it just goes over chapter by chapter and has very intense mathematical explanations of what goes on. Which again, while this is true for like somebody who's really deep into this stuff, but not ideal for somebody being introduced to it for the first time. Instead, what if you had some type of interactive textbook where you would say, what is electromagnetic waves? And it would like show you or read to you what it is. And then based on that, you would have another question, like how do electromagnetic waves interact with other things? Why are they invisible and whatnot? And then if you like get bored or you run out of ideas, then you can suggest that the book or the device like actually reads to you something, and then based on that, that will strike your curiosity and you'll be like, hold up, how does that happen? How does this happen? Now this can get even crazier if you have like some type of like VR set or something like that where you can interact visually and you can actually visualize the concepts a lot more. And this type of interactive teaching style, I think, will help students learn 100 times faster and it will capture the students' interest. And as much as I love books and I have tons of books laying around in my libraries, I really think that at the rate of innovation that we're going, we ought to come up with better tools and more innovative tools in education to help students and present the information in such a way that the students don't feel like they are dumb and actually are captured and intrigued by their own curiosity. First step is that we rewrite textbooks for introductory courses to do that with, again, text, visuals, and then using math as supporting equations. But then one step down the line would be this more kind of interactive, futuristic thing that I just described, which if you're able to build that, by the way, you'd probably make a lot of money. And I personally would, but I don't really have the time. I have a lot of other projects that I'm a lot more interested in. But this was just something from the top of my head, so if somebody can make it happen, go for it. Now, if you're wondering what this type of intuitive explanation of things that gets supported by the math looks like, I made a video explaining Maxwell's equations, so you can watch and understand the style of teaching that I'm talking about. So I'll see you there. Peace, love.